I now take great pleasure in introducing to you Dr. Mohamed Abdel-Salam, who is the Chief Researcher Emeritus of the Cotton Research Institute at Giza. Dr. Abdel-Salam will give a presentation on his overview of research findings on fiber structure in relation to quality of Egyptian cotton. Thank you, Dr.
Thank you very much. First, I would like to mention that I thought that the text of the paper would be distributed so as to make the presentation much easier and useful. Anyway, I'll try to explain it in a very simple manner, as much as I can. I think all people working on cotton improvement agree that a clear understanding of and accurate information about cotton fiber growth, structure, and the quality properties are of primary importance to all those who are engaged in cotton improvement. So we have several approaches for improving the cotton. The first one is breeding. The second one is production practices, as well as the third one, conversion of raw fibers into finished end products. This fact has been recognized in Egypt since the early 20th century. The cotton fiber and spinning laboratories of Giza acted as a link between breeders and producers on one hand, and processors on the other side. The information gathered through decades contributed to the improvement of quality of Egyptian cotton achieved in the past, present, and still constitutes a strong base for further improvement in the future. If we wanted to have a general idea about the cotton fiber and every effort to improve cotton fibers or fibers of cotton in general, there are a first point that should be understood very clearly, which is the growth and the structure. Because the physical properties of the cotton fiber are a simple expression of its fine and gross structural properties set up mainly during its growth within the body on the cotton plant. However, these structural properties are modified to some extent by environmental conditions prevailing after bond opening, such as picking and gelling. Therefore, the starting point of any effort to improve, modify, or even engineer its commercial characteristics to best suit the requirements of users in general and the spinners in particular should be based on a clear understanding of its early history of growth and development from the day of flower opening. Three fiber growth structural properties and the three fine structural properties are of paramount importance, and all are determined in the field, I mean the cotton field. The first growth fiber properties. These include fiber diameter or intrinsic fineness, fiber length and length uniformity, and fiber maturity. The second is fine structural properties, which includes the spiral angle or cellulose molecular orientation, the structural reversals, and fiber convolutions. All structural properties influence fiber tensile properties, strength, elongation, stiffness, and toughness, as well as nimbleness. An important finding has been the construction of a hypothetical relation between fiber dimensions, length and diameter, and spiral angle, and consequently fiber strength. Increase in length and decrease in diameter would result in a smaller spiral angle, and consequently higher fiber strength. This finding is of special importance to breeders to give more attention to diameter. In fact, until very recently, everybody thought that the three important characteristics of cotton are length, fineness, and fineness, because there was no available method to measure intrinsic fineness. Fineness is usually measured as what we call micromeasuring or weight per unit length, which is very misleading. When we came to the conclusion about this hypothetical structure, we understood very clearly that Egyptian cotton varieties are we clarified that Egyptian cotton fibers have peculiar quality level because mainly of their diameter. There are many cotton varieties which have the same length or even longer staple than Egyptian cottons, but are of lower quality. But we knew that it is because of the smaller diameter of the Egyptian cottons that which lead to a better quality. Because we noted that the spiral angle which controls fiber strength depends on both length and intrinsic fineness or diameter. As the fiber becomes longer and its diameter becomes smaller, the spiral angle becomes steeper, and then the fiber becomes of much better strength. This general phenomenon applies to all varieties, but doesn't apply strictly to the successive layers of the cellulose in the fiber itself. Because the cotton fiber consists of several layers, the cellulose orientation in the different layers varies according to general length and diameter, but is affected by the activity of the process of cellulose deposition during the growth of the fiber. Fiber tensile properties depend mainly on the spiral angle. The steeper the spiral, the stronger the fiber. But this relation is modified by the presence of weak points that cause premature breakage of the fibers when stretched, as can be seen from the following table. As we can see, the different varieties vary in the loss due to the weak points in the fiber. Fiber tensile properties is determined mainly by the spiral angle, but these weak points modify this relation. So in an extra long stable variety, Giza 45, we find that 11% of the fibers break immaturely or prematurely when stretching. This results in 6% loss of strength, 6% in extension, and also 11% in work of rush. Another variety like Bandara loses 48% of its, loses 24% of its strength, 16% of its extension, 32% of its work abruption. So the varieties differ or show very large range of difference. So we always take this in mind when selecting for new varieties. Another important finding which we found in cotton and which is not known to many people is the role of convolutions in fiber extensibility. Cotton fibers usually convolute as they dry. After the wool opens, the fibers dry and convolutions appear in the fiber. These convolutions, because it changes their direction from right hand to left hand at different intervals, then we found that if this is extended, if a cotton fiber is extended, the convolutions unfold and then contributes to fiber extensibility. This is an important finding because it led us to a general conclusion that to obtain a better variety, then this variety should be of intermediate maturity. The old idea is that the higher maturity is very likely or very wanted, but we found that very high mature fibers usually have little or fewer numbers of convolutions. Then their convolution won't contribute much to extensibility. An important quality characteristic in cotton is nippiness. And another important one is stickiness. These are important defects that should be put under control through breeding and production practices. We found that nippiness depends on fineness, length, but also the most important thing is that it is a variety characteristic. By this we mean that we can find two varieties of the same fiber length, of the same fiber fineness, but differ in their nippiness potential. So we came to the conclusion that to control this defect in Egyptian cottons, all cottons or new strains in cotton should be tested for nippiness at an early stage, so we can avoid breeding varieties with higher nippiness potential. Another characteristic which is regarded as defect is the stickiness. The stickiness is due to the presence of soluble sugars on the surface of the fiber. In Egyptian cotton, the percentage of sugars is very low, about 0.3 or less than 0.3%. So it doesn't cause any trouble in spinning, unless in some cases which is due to insect infestation. So we came to the conclusion that we can control both nippiness and stickiness through breeding and through agricultural practices. In conclusion, we found that our work in the cotton should concentrate on building or constructing a model for the cotton breeder, the cotton producer, and the spinners, and also in the future for the genetic engineering, for improving cotton through genetic engineering. So we say that quality improvement approaches, we have these quality approaches. First, fiber quality parameters as looked at by the spinner, and the origins of these parameters as looked at by the fiber specialists, and accordingly the discipline or means of change and what should be done to achieve future improvement has been defined. We actually constructed models for the cotton breeder, what should he do to select better quality varieties. Also, we put models for the producer, I mean the agricultural producers, to specify the methods or the ways to minimize the defects and to improve the quality. We also put some suggestions for the people working in genetic engineering, how to improve cotton through breeding new varieties in the future. I try to just give a general idea about the work done. I hope this is clear as much as possible. Well, thank you very much.
Thank you, Dr. Abdel-Salam, on this wonderful insight into your studies, into the properties of fiber structure and its effect on quality of cotton, performance of cotton. Ladies and gentlemen, I think we are making good time, and if there are people who wish to ask questions, I shall allow questions after all the sessions are over, so we can deal with each question in a totally relaxed frame of mind.